Hello, I'm Jonathan Buck, and this is my mechatronics project for MECH307. Today, the Arduino systems that I used are housed in my rocket, and I also have a prototyping board for my servos as well. I was unable to develop my servo system and my ejection for my little Lego man that I was going to put in the nose cone. So I'll be demonstrating that in a little bit, but right now, next to the right of me, is the flight payload that was already flown, and it was supposed to record acceleration data and temperature data, but I did not secure the battery properly in this. I did not do any soldering, and how this is interfaced is with primarily just wood and wood screws. So there's a flat piece of wood where the Arduino and all the sensors sit on, and then there's bulkheads that interface with the parachute and the shock cord. And if you don't know what a bulkhead is, it's just a circular disc, and one is aluminum and then the other is wood. The wood one has wood screws that are drilled into it, and that is to secure the nose cone during flight and the payload during flight as well. And I was fortunate enough to get my level 2 certification for that, which means that the rocket and its payload came back in a good condition, which allowed me to fly again if I wanted to with some minor modifications. The shock cord strings for the parachute separated, so I would just have to fix that with some tape. Other than that, there are several improvements that I would do to this payload. If I had a different launch window, if I was a little bit more flexible, I would include my servo system that would eject the little Lego man into the nose cone so he would rattle around in there. And the reason why I wouldn't deploy him on the side of the rocket is that I would like to recover him just because I don't want to pollute anything on the launch field as well. Other than that, I want to demonstrate here the prototype for the ejection system for the Lego man, and I also want to detail how the payload works when it is powered up. Alright, so as you can see, here's the little Lego man. He's in place. He's not going to move. How I would actually make this, I would cut this down and do a more triangular shape and stretch the rubber bands further to fit it into the nose cone. It's going to be on a minute delay here, and it should just release the little Lego man. So he's like free to go about wherever, and the vibrations from launch, even though as you can see he's still kind of in contact with the rubber bands, he's free to do whatever he wants. Accelerations and vibrations will move him throughout the entire nose cone here. So I would modify that piece of wood to fit in here with the rest of the payload as well. This is the SD card. This is the green LED. This is the active buzzer. This is the servo. The accelerometer is right here, attached right here with the Mega Arduino. These are both bolted in with wood screws. And there's just this piece of wood right here. My friend Peter just made this piece of wood for me as well. But I made the bulkheads by myself, so I used this quick link system. I also made this ISO grid to save on mass, and then these are all bolted together. And then the battery right here, this 9 volt, sit in right here, or at least it was supposed to sit right here. Ooh, my bad. And then it attaches right up here. And it should, in theory, start working. So we have that light there, and then, yep. I tried to mimic sort of a sound like Sputnik, but it didn't really come out that way because it was muffled. But it was supposed to sit in here like this, nested in here, and then I had this taped here down here, but I did not have this taped. So that was my issue with this right here. So, and then the quick link is attached to the shock cord and parachute system. These Kevlar looking blanket things protect the parachute from the ejection system. So that's all I wanted to show about the internals. And then now I'm going to show you how I would mount it. Alright, so this is how this would interface. You just put it on here like this, and then just try to find the holes. So, and then as you can hear, the servo and the active buzzer. Here is the wood screw going into the nose cone, and we had 4 of them in here radially or perpendicular. And right here you can see there's a little hole, and where is the other one? Right here, for temperature data. Even with 1 wood screw, this thing is being held down. So technically I could have probably gotten away with 2. This thing is not budging. I'm just doing this kind of not as professional and just more informal, just to show you how this would interface with the rocket. But then you just put the shock cord parachute in, and then the nose cone sits on top here. The accelerometer and the micro SD card reader accepts 5 volts, but they have their own regulators for 3.3 volts because they operate both at 3.3 volts. So I just decided to, for simplicity, just to run everything on a breadboard and tape everything up and just have 1 power source, and then the Arduino itself would supply that breadboard with 5 volts. Not a lot of current being drawn from this system. There was 2 issues that I would have improved upon. After post-flight analysis, I realized that the text file I was saving on the SD card was not compatible with Excel. Instead of saying write to a text file, then I would write to an CSV file. And then also, if I had more time, I would solder everything to a PCB board rather than just have it slap everything on a breadboard. So the way I designed the housing though for the payload is that to ensure that all the stresses would go through the housing and not the Arduino or its sensors. And in the nose cone as well, I drilled out a little holes, I think about 1/4 inch holes, just so we could get some temperature data. One interesting thing though is that we were able to see from just the text file is that as soon as we prepped the payload and put it on the launch pad, the temperature started increasing quite dramatically, just having everything in there. So that it had poor circulation, so that's something else I could improve upon. The accelerometer would just record acceleration data in 3 axes, and then also a temperature data as well. And the way I would store them is that each accelerometer data value and temperature value will get its own column. So the X, Y, and Z would get their own column of data for acceleration, and then temperature data would get its own column of data, and that would be in Celsius. However, during launch, I forgot to attach the battery adapter properly. I did not tape that, and what happened is that as soon as launch occurred, the battery was ejected and disconnected the entire system. And then the payload itself basically just became dumb. However, it did record a lot of passive values in the X, Y, and Z, and then that would be in G's, so just gravitational. So if 1 would be 9.81 meters per second. This rocket's been flown 3 times. That was its 3rd flight, and that was my level 2 certification, which is great. And I also want to show you guys some video footage of that as well.
We're going to go in 5, 4, 3, 2, 1.
Thank you for listening, and I will catch you all later.